In order to keep the session concise, focused, and to the point, we are going to assume that you have some familiarity with System Manager. System Manager is the built-in graphical user interface used to tune and balance the Lencore sound masking system. We will, of course, be reviewing its role and operation as we go along, enough to make sure that you know where to start. For example, you will certainly want to review how to create masking zones. System Manager is powerful while remaining simple to use. Please take the time to review and understand how it functions. We want you to be comfortable using System Manager. After referencing the user guide and viewing this webinar, should you still have questions, Lencore Technical Support is here to assist you. Reach us at 516-682-9292. Thank you for participating in Lencore's Tuning and Balancing webinar. We think the session will leave you feeling more comfortable with both the tools and concepts of tuning and balancing. We begin by covering the basics of sound masking. Next, we review the technical concepts and listening skills to enable you to successfully tune and balance the Lencore sound masking system. Sound masking introduces a spectrum of noise which gently raises the ambient background sound in order to cover or mask speech. Speech privacy is achieved by raising the noise level to a point that makes conversations unintelligible. Comfort is achieved through the quality and range of the sound produced. If the sound masking is uncomfortable, it will be turned off. The two criteria for a successful sound masking system are speech privacy and comfort. So, how do we accomplish this? We start with uniformity of sound. The right sound is broadband, the right curve, set at the correct sound pressure levels, or SPL. Sound masking occurs all around us. Some of nature's sound masking, like the ocean or a gentle brook, help us enjoy our environment without us even realizing it. Other, more intrusive forms of sound masking, say a lawnmower or a low-flying jet, are highly effective at raising the level of speech unintelligibility and covering speech, and they are extremely uncomfortable. Lencore's sound masking has been innovated for comfort. Let's get a little bit technical. White noise. White noise is an equal level of energy at all frequencies. Sounds like static. Pink noise. An equal level of energy at all octaves, more bass, warmer, more comfortable. The Lencore sound masking is a unique, custom-tailored sound innovated to be the most comfortable in the industry. It's neither white or pink. System Manager is our graphical user interface. It's built into the Lencore system. System Manager is used to tune and balance the space. Using only two controls, the sound masking levels and curve are adjusted to properly set the sound masking levels. We'll be spending some time with System Manager a little further ahead in the webinar. Let's start looking at measuring sound. The decibel is the unit of measurement of the loudness of sound or the strength of a signal. For example, The average level of conversational speech is about 60 to 65 decibels. Take a moment to scan the chart. It's a good snapshot of what some typical volumes in our world are. When talking about measuring sound, we are talking about the overall sound pressure level, or SPL for short. Again, this loudness or strength is measured in decibels. How does sound masking work? Let's start by looking at office background noise. The office environment, though built and designed to be free of unnecessary noise, will of course have its own particular background noise, without occupants. This background noise is measurable, and it is important to take note of the background noise levels. Some noises, like HVAC, will be part of the tuning of the space and when not balanced can make for a noisy environment and/or cause sound masking tuning challenges. Though variable, we estimate the background noise levels to be at least 38 decibels and often can be much louder. Let's discuss direct and indirect speech. Direct speech occurs when we are conversing at a typical proximity, say within a few to 15 feet. Indirect speech is sound arriving from some distance away, yet is easily understood. This is distracting and can lead to diminished levels of productivity and comfort. Lencore sound masking has been innovated to reduce distraction by making indirect speech unintelligible and therefore less distracting. Like if you said to yourself, "If I can't understand what is being said, I'm really not interested." Looking at the graph, notice the gray background noise represented by the white line. The green line represents direct speech at about 65 decibels. Lastly, the orange line represents indirect speech arriving at our ears at about 48 decibels. I'm sure you have figured out by now that sound masking targets the indirect speech. Indeed, sound masking is installed to interfere with indirect speech and noise. Now, when looking at the graph, notice the light gray area peaking at 48 dB. This represents the sound masking. This will cover or interfere with the indirect speech frequencies, rendering them unintelligible. When the sound masking is properly tuned and balanced, the space will be free from distractions and it will do so comfortably. Let's get prepared to visit the site. Let's take a look at what you will need for your site visit. To begin, you will need a way of measuring the sound masking levels. This tool can be hardware, software, or a combination of both. Whichever tool you choose to use, it is of paramount importance that the tool be capable of using the A weighting measuring scale. A weighting is one of the most commonly used curves. A weighting is applied to instrument-measured sound levels to account for the relative loudness perceived by the human ear. Selecting a quality sound pressure level meter is important. Lencore uses the Simpson 884-2. Pick a quality meter with A weighting. Continuing on with what you will need. You will need a laptop or other hardware for connecting to the Lencore system. An Ethernet cable, one that is long enough to get you out of the closet. I do recommend you set up your own Wi-Fi network to access the system wirelessly. We will not be covering how to set up your own Wi-Fi network during this session. I mention this to you now as it's something you may want to think about going forward. For measuring the sound, you will need a hardware or software meter or a combination of hardware and software. It is important to keep in mind that whichever application or hardware you use, it must be capable of the 1/3 octave option. You will need a calibrated omnidirectional microphone. You may access the Lencore system, known as System Manager, using any web browser. I do suggest you take some time to visit Lencore.com and download the System Manager User Guide. As indicated on the previous slide, accessing the Lencore system is as easy as launching a web browser. There is nothing to download to operate the Lencore system as the interface is built in. And just to repeat myself, spending some time with the System Manager User Guide will certainly prove to be beneficial. Conditions for tuning and balancing. Let's discuss when to perform your tunings. Now, tuning and balancing typically takes place before or after regular business hours, or you may have daytime access in an unoccupied space. Schedule accordingly. Importantly, sound masking should not be introduced into the space while it is occupied by the employees. The space needs to be quiet, minimal or no voices, no other trades, cleaning crews, or any other noisemakers. Although not always easy to arrange, it shouldn't be overly complicated to set up a time for your tuning that works for everybody. Connecting to the system. Connecting to the Lencore system requires that you make a static IP connection to the head end using a laptop. We are not going to cover how to make a static IP connection during this session. The System Manager User Guide will take you through those simple steps, and do not be concerned. You do not need to be an IT guru to make this happen. Let's take a look at masking zones. Creating masking zones enables the tuner to set levels that incorporate multiple operating platforms and their channels. Using masking zones, the tuner can more easily tune large areas efficiently, accurately, and in less time. Let's take a look and see how this works. Review your diagram and create your masking zone plan. I like to set this up prior to arriving on site. By planning your zones ahead of time, you will be able to arrive on site and get right to it. Review your site drawings. Always bring printed copies to the site for your notations and masking zone references. You will create a map or legend of potential masking zones. Build your masking zone list from operating platforms and operating platform channels. Write them down on your wiring diagram for your reference. Again, I highly suggest that you do this prior to your tuning. Zones are created based on the type of space you are tuning. We call them acoustically distinguishable spaces. Open areas, closed offices, hallways are all acoustically distinguishable. Looking at it this way, you can see why you create zones populated with channels that cover like spaces. I'm sure it makes perfect sense that you don't create zones with speakers installed in different types of spaces. Have a look at this chart. This is an example of a zone map. Your zones will typically be comprised of OP channels from either a single OP or many OPs. You can see from the chart that an OP may have channels in different zones. This is quite typical and is driven by the site's design and requirements. If you have taken the time to review the System Manager User Guide, connecting to and operating the system should be straightforward. With a little review, creating zones should be simple. The Lencore system, though powerful, is easy to operate. When arriving on site, you will want to confirm that the site is fully functional and that the masking is on. I like to walk the space and listen, if the masking was left on. I will also log into System Manager when arriving. If this is an INET project, you are testing the data cable and the OP health. If you are working with the A1U or Gold platform, logging into System Manager will allow you to see the two built-in OPs. Log into System Manager and create a masking zone with all OP channels. Using the masking attenuation slider, raise up the volume so that you can hear the sound masking clearly. Walk the space and confirm the sound masking is on throughout. It's important that you notate any issues that you encounter. Minor issues, such as a speaker being out or a single channel not functioning, will not prevent you from tuning the remainder of the space. After completing your walkthrough, return to System Manager and bring the zone masking attenuation slider all the way down to 34. 34 is our off position. Okay, let's start measuring sound pressure levels. Remember, Whichever tool you select for measuring the sound pressure levels, that tool must have A weighting available. You may recall that A weighting most closely mimics the way that human beings hear. Just a few moments ago, using System Manager, you brought the sound masking levels down to their off position. With the sound masking off, we can measure the ambient levels in the space as they are without the sound masking. Begin by holding your meter at waist high, or about 4 feet off the ground. Position the meter at approximately a 45-degree angle. Now, slowly wave or move the meter from side to side for approximately 30 seconds. If there is noise in the space, such as voices or cleaning crews, this will prove to make measuring difficult. Again, you'll want to plan accordingly to ensure that you can have the quiet moments you need to accurately tune and balance the space. Let's go back to System Manager. In System Manager, you will use both the masking attenuation and masking contour controls. The masking attenuation slider adjusts the overall volume. You can move the slider and you may also type in a value. As an aside, the numbers on the sliders do not correspond with a specific decibel level. They are simply numbers for reference and reporting. The contour slider adjusts the Lencore curve. Moving the contour slider up shifts the Lencore curve towards a more white noise dominant curve, hissy. Moving the contour slider down moves the Lencore curve to a more pink noise dominant curve, warmer. It is critical to balance these sources to raise the level of speech unintelligibility while the masking remains comfortable to work under. Too much white noise is highly effective and highly uncomfortable, like a lawnmower. Too much pink noise is warm and comfortable like your favorite sweater, but it does not provide sound masking on its own. Measure and reach your target levels while also using your ears. With enough trial and error and experience, your understanding of what a properly tuned space sounds like will evolve. Ensure you set the level and contour accordingly and do not be afraid of making drastic adjustments in order to really hear the difference. Try to have some fun while learning and tuning. Think about it this way. If it doesn't sound good to you, it won't sound good to the occupants. If you're uncomfortable, they will be uncomfortable. Tuning and balancing using System Manager is all about zones. Why tune each OP one channel at a time when you can combine OP channels into zones for fast, efficient tuning? If you recall, I mentioned earlier that a little homework can go a long way towards saving you time when arriving on site. If you did your homework, you will have your masking zones designated on your wiring diagram for reference. This will enable you to quickly create your zones and begin tuning. If available, always start with a large open area. Once the tuning in the open space is completed, you have likely tuned the majority of the project or floor where the sound masking has been installed. Open areas are much easier to hear and to get a sense of where you need to be with regard to levels and contour. No doubt that trial and error is the rule of the day. 48 decibels in the open area is your target masking level. Use the same measuring techniques employed earlier while we were taking measurements of the background noise levels. Use both masking attenuation and contour controls to achieve the best results. It is very important that you tune and measure in several locations and notate those decibel levels on your wiring diagram. Typically, I will place these numbers next to the background noise level measurements made earlier. It's a good idea to write down your masking, attenuation, and contour controls from the zones you've already created for the first floor. You can apply these settings to zones on additional floors. Jot down your existing settings for all repeatable zone types to use on the next floor. Simply create your zones for the second floor. Once the zone is created, move the masking attenuation slider up or down, leaving it on the number you notated from the first floor zone. Do the same with the masking contour control. This will set all the OP channels to the same settings as the first floor. Again, as an example, after you have created zones for the next floor, do the following. Move the zone masking attenuation slider up one click, then back down one click. Move the zone masking contour slider up one click, then back down one click. All channels included in the zone are now set to the same masking and contour levels as the zones on the previous floor. Do this for all zones. Measure all newly added areas in several locations to ensure uniformity of masking levels throughout the open area or other zones. Notate the levels on your wiring diagram. Reviewing target decibel levels. Open areas, target 48 decibels. Closed offices, target between 42 and 45 decibels. Hallways or transitional spaces, your levels will vary. Keep in mind the goal is to not have hot spots or cold spots. Give your full attention to the transition from an office to an open area, from an open area to a hallway. Anytime you are moving from one space to another, the sound masking should not be noticed. Should you encounter a channel or channels in the zone that requires adjusting, it's best to pull them out of the zone and tune them individually. I'm simply making you aware of the fact that sites can be quirky and that tuning and balancing does have its nuances. Patience and good ears can and will go a very long way. Few sites are 100% cookie cutter. Here's an important note. The output or personality of the operating platform channels is set by the controls that you adjust last. Move the Zone Master attenuation slider and the OPs will follow. Move an individual OP channel slider and it follows that change. They override one another. Any channel included in a zone can always be adjusted with the zone or the individual OP channel controls. If you adjust the individual channel, then make a change to the zone it is included in, the channel will follow the zone control adjustment because that was the last change. Remember, whichever control you touch last sets the channel's output. I wanted to circle back to transitional spaces. What is a transitional space? These will include offices, hallways, or any areas along the route where masking is installed. After tuning a large open area, if available, you typically move to offices and hallways. When you walk through these spaces, ensure that there are no hot or cold spots. As you walk in or out of an office into the adjoining open area, the masking should not be noticed. Wherever there is masking, transitions from space to space will be seamless when properly tuned. Okay, once you have completed tuning and balancing of your first area or zone, follow that process for the remaining spaces. Remember, use your existing settings and apply them to like spaces. Just tuned an open area? Those settings will very likely get you close to where you need to be in additional open areas. Will you need to make adjustments? Maybe yes, maybe no. As you measure the new area, make any needed changes to the masking attenuation and contour. As a reminder, continue to notate your levels and any nuances on the wiring diagram. As you proceed with your tuning, it's a good idea to save to flash. This ensures your settings are stored in the OPs. You will find that feature on the System tab in System Manager. You will also be prompted to save to flash as you log out. Do not turn power off on the system until you have completed this step. Once you have completed your tuning and balancing, you will generate an OP report. If you reviewed the System Manager User Guide, you will have come across this important step and just may be familiar with the process. In System Manager, from the System tab, you will select the Generate OP Report option and follow the steps. The report will be downloaded to your local drive. The CSV file contains all current OP settings. This will include the masking and contour levels and zone assignments. I cannot stress enough the importance of this document. With this document, the system can be reset should unwanted changes be made to the tuning or to set up a replacement OP. Please submit this to Lencore along with any closeout documents. This concludes our webinar, Tuning and Balancing the Basics. Thank you for taking the time.